Well, I was going to talk a lot about many of the things that this panel has talked about, but having heard it, and they spoke so eloquently, I'm just going to wing it. So George Post has written about the fact that there are 150,000 papers on biomarkers. And if you take a sort of off the back of the envelope calculation that says each of these papers consumes about $100,000 in resources, whether that's NIH resources or academic or private pharma or what have you, that works out to about $15 billion that we've spent on the biomarker effort. Now, again, you can quibble with the figures, but it's a lot. Because we've been doing this for a long time, and I focus on cancer research, where in the 1970s we call these neoplastic antigens. That was the term of art, and you can search through the literature and you'll find it. Tumor markers was the term of art in the 80s and 90s, and now we've got this ethereal biomarkers, which is a wonderful term, but it's an old problem. It's an old problem that we continue to look at, and we know this is the linchpin for success. We know this is the key, particularly in cancer and heart disease, where it has worked, of diagnosing disease early, of catching it early when it's most treatable, most curable, and has the least burden on individuals in terms of that treatment, and society in terms of its cost. So it's a win-win-win when you catch something early. And out of those 150,000 biomarker papers, Anna talked about the fact that we've got about 100 or so in use in all diseases. Most of those are for sort of monitoring disease and monitoring response to treatment and understanding when diseases return. So for example, CA125 is a great marker for ovarian cancer if you've already had cancer and you've been treated and it's recurring. But it's not so good for identifying people who may have the cancer, who are otherwise healthy, or who may even present with, say, a pelvic mass or something. So our problem is that we don't have very, very good markers that are both sensitive enough and specific enough to identify people who are having those diseases and who need treatment. And when you have a bad marker or an iffy marker, the cost of that is sometimes worse than having no marker at all. Because when you have a test like that, what follows generally is some sort of intervention. And those interventions can be surgical, they can have profound consequences in themselves, and they're expensive. And so we've seen this problem, and we've heard it all, and it's been written about quite a bit, overdiagnosis, which is when you have people who may not have a specific disease being overdiagnosed or improperly diagnosed with that disease. All of this has to be addressed with biomarkers. It's their only way forward. So I've been thinking a little bit about what each speaker has said, and I think they've covered all the bases, I really do. But there are two issues that I keep coming back to. One is standards that everyone has talked about, so critical. And the other is critical mass. So let's think for a minute about what works in our daily lives. How many of you use Google, or Wikipedia, or Facebook, or LinkedIn, or any of these sort of tools of the new world? All of you, I imagine. And they're such an important part of your lives that we take them all for granted. But think about how they came into being. The first is through standards. Without language, without HTML, without internet protocols, without rules of engagement, we wouldn't have any of these things. They're so critical. If you put an extra W in your URL, you're not going to get any of these things. Every one of them has, for the way packets of digital information are put we talked about highways, on all of these access roads into the internet, every one of them conforms to various protocols, and that works. The final part of this is critical mass. And think about the names that I just said. I didn't say Alta Vista, and I didn't say MySpace, and I didn't say a couple of these others. It's because it's important that you get this buy-in from all of the various stakeholders for something to work. We have, as George said, 150,000 papers on biomarkers. Many of these are done with sloppy science. They're not validated. They're not reproducible. And so we have all of these candidates, but no final answers. Very, very few of them. In terms of, Ann had mentioned 1.5 protein markers approved per year, but in cancer, in terms of diagnosing a new illness, we have 2, both of which were recently approved for ovarian cancer, and neither of them really gets much buy-in from the community. So the key is to focus, and this is why I think an effort like this is so important, is because we've got to be able to get everybody in the same room and get a critical mass so that we can have biomarkers that actually mean something in a clinical sense. So thank you for inviting me, and it's a pleasure. Thanks.